Okay, let's see if I can help you out here a little bit with your rational root theorem. So I'm getting this off of, it starts on page 329 in your book. I'll write that up here, page 329. Okay, so basically this rational root theorem is basically saying you can find a root by using this P over Q thing. So P over Q is basically, the P stands for factors of your constant. So the top one is the factors of your constant. So in this case, this is the last problem, by the way, the last problem that you're talking about on your review. So the first one is the factors of your constant. So basically your factors of negative 45, which could be like negative 45. It could be 1. It could be 5, 9, negative 5, negative 9, any of those, okay? And then your factors of your constant is the last one. So the bottom one is the factors of, not your constant, of your leading coefficient. So in this case, we're talking about 2, okay? So the first step, your book says, the first step in this is like list all of the possible rational roots that you could have. So I went through and I started to list all of the possible rational roots. So I started with 45. So 45, negative 45, and positive 45. All of them, when your last term is negative, I'm going to say plus or minus because you can have positive 45 or negative 45. So starting with negative 40, positive or minus 45, I could say you could do 45 over 1 is one of them because 1's a factor of this term, your leading coefficient, and 45 is a factor of the last term, right? Okay, so I can do plus or minus 45 over 1. I can do plus or minus 45 over 2. I can do plus or minus 9 over 1. I can do plus or minus 9 over 2. I can do plus or minus 5 over 1. I can do plus or minus 5 over 2. All the top numbers, factors of negative 45. All the bottom numbers, factors of 2. Okay? You can keep going. 3 goes into 45, so I can do plus or minus 3 over 1, or plus or minus 3 over 2, or plus or minus 15 over 1, or plus or minus 15 over 2. 1 also goes into 45, so I could do 1 over 2, or I can do 2 over 2, which is just 1. Okay? So then what your book is saying to do, the next thing, once you've listed all of them, what you need to do, these should all be plus or minus, sorry. There's so many that we can try that I think that's ridiculous to have to try them all. But what you have to do next is take one of these and plug it in and see if you get 0, because you're trying to find one that equals 0. So what I did is I went through and I just graphed it. And I was like, all right, which one am I going to try? Because I'm not going to try one if it doesn't actually hit the x-axis. So I noticed it hits the x-axis at negative 9. And so I was like, all right, that's one of my factors, or that's one of my roots, is negative 9. The other two, I think you wrote the other two were like 1.58 something and negative 1.58 something. I'm going to show you how to get those as well. But since negative 9 is the one that's rational, then I'm going to take that. If you take that negative 9 and you plug it in for x and do like 2 times negative 9 to the third power plus 18 times negative 9 to the second power minus 5 times negative 9 minus 45. If I take the negative 9 and I plug it in, you're going to get 0. So it definitely is a root. So once you have one of the roots, you can figure out your other 2 roots by then doing synthetic division. So I'm going to do that now. So one of the roots is negative 9, and I got that from this list. Okay, so I'm going to take that, and I'm going to take the 2x to the third plus 18x squared minus 5x minus 45, and I'm going to go ahead and I'm going to do synthetic division with it. And I'm going to divide it by, since my root is negative 9, I'm going to divide it by negative 9. So negative 9, I'm going to take into this. So my coefficients are 2, 18, negative 5, negative 45. And I'm pretty sure you know how to do this part, so I'm just going to do it fast. So the 2 comes down, negative 18, that gives you 0. You get 0 here, so that's negative 5. And then you get positive 45, so that's 0. That last thing, if your remainder is 0, that means that negative 9 is actually a factor. Negative 9 is actually a root. It goes into it, okay? So what that means is that this guy, since it's a root, if you were to factor this guy, that means x plus 9 is a factor, right? So now if you notice, this guy is your other factor. This is your x squared term. This is your constant. This is your x term. So this would be 2x squared minus 5. And so if we're trying to figure out our roots, what we're trying to do, this right here is going to give you that negative 9. But this is going to give me the other two roots. So if you think about setting 2x squared minus 5 equals 0, add 5 to both sides, so you get 2x squared equals 5, then you divide by 2, and you get that x squared equals 5 over 2. And then you find the square root of both sides. And so remember, when you find the square root of both sides, it's plus or minus, right? So that means x is equal to plus or minus the square root of 5 over 2. Now if you find on your calculator the square root of 5 over 2, that's your irrational root, okay? It gives you that decimal, 1.58 something, and negative 1.58 something. So your roots, those are your other two roots. So your roots are negative 9 and plus or minus the square root of 5 over 2, which that's not in simplest form. I don't know if you have to put that in simplest form. The square root of 5 over 2 in simplest form would be plus or minus the square root of 10 over 2, because remember, you're not allowed to have a radical in your denominator, so if you multiply the top and the bottom by radical 2, and this is radical 2, this gives you the 2 at the bottom, and 5 times 2 is 10. So your roots are negative 9, positive 10 square root of 10 over 2, and negative square root of 10 over 2. Okay? So synthetic division, I'm pretty sure what that does is that if you know one of the roots and you use synthetic division, what's left here is the other polynomial that you have. Okay? So hopefully that was helpful. But also use your calculator to find those roots, and then you use that information to help you figure out where to go from there. Okay? So the other ones, the Descartes' rule of signs. I'm not sure if I'm saying that name right or not, but that guy, we were doing that totally right. So that first one that said x to the 5th minus 7x to the 4th plus 17x to the 3rd minus 19x squared plus 16x minus 12. So when you're doing the positive, negative, imaginary thing, so you were right. We were right. So you're looking at the number of sign changes. So this would be positive. So it does change 5 total times. So it does change 5 total times, which means there could be 5 possible roots. Because the highest exponent is 5, that's how many possible solutions that you could have. So if there are 5 possible, then yes, these two have to be 0. Okay? So then the negative, if you put negatives in here, which we did that too, if you put negatives in here, then that makes, that's going to change your signs, and we found that you have 0 sign changes. So we know there are 0 negatives. So the rule is saying that because imaginary solutions travel in pairs, which is something I learned today, I didn't actually know that, imaginary solutions, they have to be pairs. So if you have one imaginary solution, one imaginary factor, you have to have another imaginary factor, which is why if you're subtracting by 2 here, okay, so 5 minus 2 is 3, and then the reason you get 1 is because you can keep subtracting by 2. Most of the examples you've probably been given haven't been as high as 5, okay? So that's where the 1 comes from. And then, of course, if there are 3, then there's got to be 2 here. If there's 1, there's got to be 4 here. That's the reason you're subtracting 2, because these imaginary guys, these guys right here, they travel in pairs, always, okay? So now, we graphed this and only saw that there are 2 actual roots where you're like, wait, but there should be at least 5 or 3 or 1, which then I spent a long time thinking about and then realized, oh yeah, one of your roots can repeat. And what I found when I did synthetic division, if I divided this thing by a root of 2, because when you graphed it, your roots were, I can't remember what they were 2 and something else. I can't remember what it was, but I graphed it again. I know 2 was one of them. I found that 2 actually happens twice. Okay, so you're going to have, your factors are going to be like x minus 2 and x minus 2, and then x minus, I can't remember what the other one was. I think it was like 4 or 5. I can't remember what that other one was, but if you look at your graphing calculator. So if really, you could have 3 possible roots, just one of them repeats itself. I'm not sure if the other one repeats itself or not, but that wasn't the question. The question was, come up with this chart, basically, and then find out what your roots are. Just go ahead and graph it to find out what your roots are. But don't get confused if there aren't 5, 3, or 1, because one of them could repeat itself. So that was the little tricky thing there. So then number 3, or no, I don't know if it's number 3, but the other one that you were having trouble with the rule thing, the rule of signs. So that was the one that said x to the third minus 3x squared minus 5x plus 15 equals 0. For positive roots, again, and I'll be honest, because you didn't give me the answer to this one, or I didn't look at the answer to this one. I'm not sure if I'm right, so you should check your answer key to make sure that I'm right. I hope I'm right. So I found, because the highest degree, because the degree of this thing is 3, there could be a maximum of 3 roots. There could be less than that, okay? So I found the sign changes here is, since this is positive, it changes once, doesn't change here, changes twice. So the highest possible positive is 2, right? And so then to get the negatives, you're going to put negative x in here. Remember, all the odd ones are going to be negative, and all the even ones aren't. The sign's not going to change. So when you put negative x in here, it then becomes negative x to the third. This one's even, so it's going to stay x to the second. This one's odd, so it's going to become positive 5x, and then plus 15. So that's the negatives. And all I did was think about if I'm doing negative to the third power, negative to the second power, okay? So this only changes one time. So that means there's a possible of 1, okay? So that means negative could be 1. So this is what I'm thinking. I'm thinking because there's 2 positives, and if you subtract 2 from that, you can have 2 or 0. You can't go down into negative, so that's why it's either 2 or 0. You have 1 possible negative, but you have a possible of 3 total roots. So it could go like this. It could go 2, 1, 0 imaginary, but then if you have 0 positives, since the imaginaries have to travel in pairs and the negatives don't, you could have 1 negative here and 2 imaginary there, okay? The way to get the roots for this, I would say just graph it on your graphing calculator, and if you can't get the exact roots, you know how to do the thing on your calculator where you're finding the zeros. Just go ahead and do that. I think that's all you have to do for that, and I think hopefully I answered all your questions. I'll send you in my email, my phone number and my email in case you need to call me. Okay? Good luck tomorrow, and hope that was helpful.